All right, so we're going to start off by talking about linear measurement. We're going to end up talking about three total types of measurement. Linear is the first one, and so I want you to start off by recording some of these conversions. I believe most of them should be reasonably familiar to you. For example, there are 12 inches in a foot. No surprise there. There are 3 feet in 1 yard. There are also 36 inches in 1 yard. There are 12 inches per foot, and there are 3 feet in a yard. There would be 36 inches in a yard. The only one that might not be just on the tip of your tongue at all times is that there are 5,280 feet in 1 mile. Below that, I've written some unit fractions, and those unit fractions are what we're going to be using to solve the bulk of our problems. What I want you to notice about all of those unit fractions is that they all equal 1. 12 inches divided by 1 foot equals 1 because 12 inches and 1 foot are the same, and anything divided by itself is 1. Same thing with 3 feet and a yard. 3 feet and 1 yard are the same. Anything divided by itself is 1. I've written the unit fractions both ways they can be written, with inches on top and with inches on bottom, then with feet on top and feet on bottom. But the point is, all of those measurements, all those fractions, are equal to 1. The reason why that's important to us is because when you multiply something by 1, what happens?
Number stays the same.
Yeah, the number stays the same. Nothing happens when you multiply by 1. So we're going to start off by doing some conversions, meaning if I ask you how many inches is 6 feet, for example, how do we convert that from feet into inches? If I give you 3 yards, how many feet is 3 yards, that sort of thing. And one of the techniques that we're going to use for doing those conversions is multiplying by the unit fractions. So it's important for us to say right up front that when you multiply by one of these fractions, you are multiplying by 1. And multiplying by 1 is an okay thing to do because multiplying by 1 does not change the value of the number. Okay? So let's do a conversion. Let's convert 8 feet to inches. So here's what I want to do. I'm converting feet to inches, which means I want to use one of my unit fractions that contains the units feet and inches. This bottom one contains feet and miles as my 2 units. This one is feet and yards, so obviously I want to use the first one, feet and inches. So I'm going to take 8 feet, I'm going to multiply it by one of my unit fractions here. So I'm going to do 8 feet. I'm going to multiply by one of my unit fractions, and it's going to give me some inches. So which of the unit fractions should we use? Should we use the one that's 12 inches over 1 foot, or should we use the one that's 1 foot over 12 inches? The way that you can tell is you use the unit fraction where the numerator is the unit you want, and the denominator is the unit you have. Unit you have. So we have feet and we want inches. So we're going to do the fraction that has inches over feet. 12 inches over 1 foot. So multiplied by 12 inches over 1 foot. The unit that we want to convert to inches. That one's on the top. And the unit that we have, the number we were given was in feet. That is on the bottom. Okay, so I'm going to multiply a whole number, which is 8, times a fraction. As you may recall from previous math courses, multiplying a whole number by a fraction is pretty simple if you turn the whole number into a fraction. Well, how do I do that? How do I turn a whole number into a fraction? You just put it over 1, like that. And now what I'm going to do is just multiply straight across. So I'm going to do 8 times 12, which is 96. And on the bottom, 1 times 1, which is 1. But what happens to the units? Well, anything you have on the top can cancel with anything you have on the bottom. So I have feet on the top. Here's feet on the bottom. Feet on the top and feet on the bottom will cancel out. And that's why I'm left with just inches. The reason it cancels out, I probably shouldn't say cancels out, that's not good math terminology. It's because, as we said right at the beginning, anything divided by itself is 1. So feet divided by feet is 1. So it's not like it's canceling out, it's turning into a 1. Having it multiplied by 1 in the problem doesn't change anything. So my answer is 96 over 1 inches, which of course I can reduce to just 96 inches. So, how many inches are there in 8 feet? 96. As we're writing out like this, maybe one of the thoughts you have is, writing the fraction part seems really stupid.
You could just 8 divided by 8, right?
Well, times. 8 times 12. Isn't that what I just did? 8 times 12? And the answer is, yeah, that is what I did. So it's a little silly to have the fraction in this problem, but I promise in a little bit we're going to do some that are difficult enough where doing the unit fraction will make sense to you. I'm just easing you in. Okay, any questions about that? You all right about that one? All right, let's do feet to yards. Let's convert 7 feet to yards. So I'm going to do 7 feet. I'm going to multiply it by something, and it's going to equal some yards. The question is, what do I multiply by? I'm going to need one of my unit fractions that includes both feet and yards. I have my measurement in feet. I would like my measurement to be in yards. So back to my unit fractions. Do I have any that have both feet and yards in them? And the answer is yeah. 3 feet is 1 yard. I can use either one of these. How do I know which one to use? Well, it's the unit that I want on top and the unit that I have on the bottom. So what do I want my answer to be in?
Yards.
Yards, and I have feet, so I'm going to use the one that's yards over feet, 1 yard over 3 feet. Okay, so I'm going to multiply by 1 yard over 3 feet. How do you multiply a whole number by a fraction? Put it over 1. Good. I've got some units that will cancel. I have feet on the top and feet on the bottom. Those will reduce to 1. Those are gone. And that's why my answer is in yards. I got only yards left. Okay, so let's do it. On the top, I have 7 times 1, which is 7. And on the bottom, I have 1 times 3, which is 3. So the answer here is 7/3 yards. 7/3 yards is fine. That's a fine answer. But how big is that? Is that enough for a first down? 7/3 yards? I would prefer to convert 7/3 into a number that means something to me. Yeah, how many times does 3 divide into 7?
Twice.
Twice, with how much left over? 1? 1 left over?
Yeah.
So 2 1/3 yards is a much better answer, just because 2 1/3 I think is an easier number to wrap your head around than 7/3. They're both correct. But if I said, wow, Tom Brady just had a 7/3 yards pickup, you might stop for a second and go, what, is that good or is that bad? He got 7/3 yards. 2 1/3, you're like, oh, that's not too great, Tom Brady. Get it together, man. You're playing in the Super Bowl. He should be careful. Tom Brady should be careful in the Super Bowl. Apparently the Rams don't get pass interference called against them. That's going to make things real tough for Tom Brady. Yeah, I'm still salty about it. Who wants to fight? Okay, moving on. Let's do something a little different.
No one play plate.
Hmm?
Not gonna talk about the play plate.
I'm from Texas, man. If the Cowboys or the Texans are not in the Super Bowl, I don't care. Okay. So we're going to do a conversion of multiple units here. I want to convert 134 inches into feet and inches. Now here's why I know it's going to be converted into feet and inches, because 134 is not a whole number of feet. I know for it to be a whole number of feet, it has to be a multiple of 12. For example, 2 feet is 24 inches. 24 is a multiple of 12. 3 feet is 36 inches. 36 is a multiple of 12. 134 is not a multiple of 12. So it's going to be some feet, but with a little bit left over, and I want to figure out how much is left over. What should I do first?
Divide or see what times 12 will get you the closest to that in inches.
Right, so kind of what you're saying is I need to find the correct unit fraction. Am I going to be like multiplying by 12 over 1 or multiplying by 1 over 12, which is dividing by 12? So I got inches and feet going on in this problem. So I need a unit fraction that has both inches and feet. That'll be the first one. What's the unit that I want, though?
You want it in feet and inches.
Yeah, I want both of them. What's the unit that I have?
You have it in inches.
I have inches, so I'm going to go ahead and use the one with inches on the bottom for now, because I have inches. So I'm going to take the 134 inches, and I'm going to multiply by 1 foot is equal to 12 inches, like that. Okay, so I'm going to turn my 134 into a fraction by putting it over 1. My inches are going to cancel out here. And it equals 134 on top. 134 times 1 is 134. And on the bottom, 1 times 12 is 12. And what's the unit of that? 134 over 12 what? Feet. Feet's the only unit I have left. Great. I'm going to go out on a limb and say if you go down to Home Depot and say, yeah, can you cut me a 2x4? I need one that's 134 twelfths feet long. They are going to have you removed from the store. 134 twelfths feet doesn't mean anything to anybody. About how many feet is that? Well, let's do some easy math. What would 10 feet be? How many inches is 10 feet? That's 120. 120 times 10, or sorry, 12 times 10 gives me 120.
Yeah.
134 is bigger than 120, so my answer I expect to be a little bit more than 10 feet. Maybe 11 feet, maybe 12 feet, somewhere in between, right? A little bit more than 10 feet. How much more is the answer to the inches part? What goes there is how much more is it than a whole number of feet? So here's what I'm going to do. This is an ancient mathematical technique here, kids, called division. A fraction line means divide. So I'm going to do 134 divided by 12. Now, before I do 134 divided by 12, before I start this, when I'm finished and I have a number here, what's that number going to mean? Feet. Exactly right. Okay, so let's go ahead and divide it. I know you all know how to divide using a calculator, but let's try to try to be impressive here. Let's do some long division. Cool. How many feet? 11 feet. But I've got a remainder. What's the remainder? 2. That is my inches. If you go to Home Depot and ask for 11 feet 2 inches, that they will give you. If you ask for 134 twelfths feet, they're going to send you to Lowe's and you're going to deserve it. that make sense? Yeah, let's go the other way. Let's convert 3 feet, 7 inches to feet. So here's my strategy for this one. I'm going to, number one, convert 3 feet into inches. Convert 3 feet to inches. That'll be my first step. And then my second step is going to be take that answer and add the 7 inches. Right? If I knew how many inches 3 feet was, I could just add 7 onto it to get 3 feet 7 inches. Does that make sense?
Yep.
How am I going to turn 3 feet into inches? What will I be multiplying by?
Well,
It's 12 inches for every 1 foot. We'll put this over 1 and multiply. My feet are canceling. Sounds painful. I'll have 36 inches. Okay, I did that kind of quick, so I'll give you just a minute to catch up. So 3 feet is 36 inches, but I didn't want 3 feet. I wanted 3 feet 7 inches. So what do? I take the 36 inches and I add the 7 inches. And that gives me 43 inches. And that is my answer, and that's how we do.
Well, you said convert.
You said convert it to
7
feet.
inches to feet.
So how can 43 be in the answer?
Oh, because I'm dumb.
Okay.
Converting it to feet, it would be 3 7/12 feet. Sorry, I can't write. But I appreciate y'all waiting until we got all the way through that problem before you mentioned my mistake in the very first line. I know you have misguided faith in me that I'm suddenly going to turn it around at the end and go, booyah! Now it's feet. Let this be a lesson to all of you. If you blindly follow me, it will lead you only to despair. All right, here we go. Let's do some addition. Cross multiplication.
I'm used to that versus this.
Cross multiplication is used when you have an equal sign.
Right.
So the method in which we're going to set up this problem will likely not come as a surprise to you. I'm going to take the 3 feet, 2 inches, and I'm going to do plus, and I'm just going to line up the second one, feet and inches, like so. And now I'm just going to add them straight down. 3 feet plus 5 feet. There we go, 8 feet. And 2 inches plus 11 inches is 13 inches. Great. Now again, if I walk into Home Depot and say, I'd like 8 feet, 13 inches, they're going to give me some weird looks. Why are they going to give me weird looks?
Because it's more than 12 foot.
Yeah, because 13 inches is more than a foot. They'd be like 8 feet, 13 inches. Why wouldn't you just say 9 feet, 1 inch? Okay, so let's talk about how we get that. 8 feet is just going to stay 8 feet. The 13 inches, though, is how much? Yeah, that's 1 foot and 1 inch. So if I put this all together, what would I get? Exactly. Just like that. Let's do multiplying. Hopefully you can see why a problem like this might be useful if you are building something that, you know, maybe is enclosed on 3 sides. Like, well, I needed 8 feet 9 inches and I need 3 of them. How much stuff should I go ask for? This one's also similar to what you would expect it to do. You take the 8 feet 9 inches and multiply by 3, meaning you multiply everything in this problem by 3.
Yeah.
So instead of 8 feet, it'll be 24. And instead of 9 inches, it'll be 27. So go down to your friends at Home Depot and say, I need 24 feet, 27 inches wood. And they're going to say, this is the 4th time today, will you please learn how to do math? And the reason they're going to be confused by what you say is because 27 inches is more than a foot. Why would you say 24 feet, 27 inches instead of
26 feet, 3 inches.
26 feet, 3 inches is correct. Here's how we get that. 27 inches is how many feet?
2 feet.
2 feet
3.
with 3 inches left over. Plus the 24 feet that we had for a grand total of 26 feet, 3 inches. Well, let's see. We did addition, we did multiplication. I feel like we've covered everything, right? Those are the big ones. That's probably all we need, right? This is like I'm making a cut here. I have something that's 6 yards, 1 foot long, and I remove 2 yards, 2 feet from it. Well, I feel like the line them up and do regular math strategy has been working for us. Let's try that again. That seems all right, yeah? Let's do it. When you're subtracting, where do you start? Way over here, the far right. 1 feet minus 2 feet. Why is that a problem?
Negative.
Yeah, it's a negative. I can't do that. Yeah, what if I borrow? We love borrowing in subtraction, right? Let's borrow from this 6 here. I'm going to take 1 yard out of the 6. That's going to make it 5 yards. How much do I then add over here? Would it be 11?
It'd be 2.
It'd be 2?
No, it'd be 4.
It'd be 11.
How many feet are in a yard?
3.
So if I take 1 yard out of here, I'm borrowing 3 feet, right?
4.
So instead of 1 foot, it will be 4 feet. I took 3 feet from the yards column and put it into the feet column. If you were thinking it was 11, and you can be forgiven for thinking that, let me explain how subtraction works. If you were to get this old school subtraction problem, your first thought would be, oh, borrow from the 4, right? That becomes a 3. And then this becomes an 11, right? But why? Why does that become an 11? It's because this is the tens column. That's not a 4, it's 40. So I took 10 away from 40, leaving me with 30, and I added that 10 into the ones column. 1 plus 10 is 11. That's how borrowing and subtraction works. I borrow 10 and add 10. It's not borrowing 1 and adding 1. And if your elementary school teacher taught you that, they owe you an apology, and I think you should go hunt them down and demand one. You're like, listen, I'm in college, and it turns out you taught me how to subtract wrong. You owe me an apology. Don't tell them it was my idea, but you should definitely go do that. What do you think? You feel okay about this kind of stuff? Yes? Okay. Now this system of measurement that we're doing with inches, feet, yards, miles, all that kind of stuff is a system of measurement called the Imperial System. And the United States is one of the only countries on Earth to use this system. Almost nobody else uses feet, inches, and yards. The United States is one of the few, which means all those other countries are wrong. But we are going to go ahead and talk a little bit about the system of measurement those other countries use, those other lesser non-American countries that use a different system. Do you know the name of the system they use?
Metric.
It's called the metric system. Irritating shop mechanics for decades.
Just like how we drive on the other side.
We drive on the right side and they drive on the left. You know why we drive on the right side? Because it's the side that's right.
Don't tell them that in England.
Everybody agrees with me except for postal delivery people. Okay, so the metric system is beautiful. I have to admit, even though it did come from a bunch of dang foreigners, I really, really like the metric system. And here's why. The metric system has some weird sounding units, but they're all based on multiples of 10, which means conversion in the metric system is easy, easy, easy. So here are the measurements for the metric system. The highest one is abbreviated km. What's the next one? HM? I'm going to tell you what these stand for in a minute. I'm just curious. Do you know what the next abbreviation is? No? It's fine if you don't. I wouldn't learn anything about other cultures either if I was you. You know what M is? That's meters. Yep. Then DAM. This is DAM. M. DM. CM. MM. I'm showing you the abbreviations first before I give you the names of them because the names are a little weird. I'll bet you know what KM stands for. What's KM? Kilometers, or kilometers, as the limey Brits would say. Or would they say kilometers? I don't know. What does Harry Potter say? HM. You know what HM is? Hectometer, or hectometer. DAM is the decameter, D-E-K-A, decameter. M is meter. DM, where all the ladies slide into, is the decimeter. CM, centimeter. You know what MM is? Millimeter, 2 L's. M-I-L-L-I. Millimeter.
Is that DEM?
Right here,
Yeah.
DAM. Decameter, DAM. Okay, so I wrote these in order for a specific reason. These are in order from largest to smallest. So kilometer is the largest.
That's like their miles.
That's like miles, yep. Millimeter is their smallest. And if I want to go from a large unit to a small unit, I multiply by 10 for each step, and I'm using air quotes here, each step that I go down. Each step you go down, you multiply by 10. Each step you go up, you divide by 10. So we're going to say, when you move left, meaning smallest to largest, you divide by 10 for each step. When you move right, meaning largest to smallest, you multiply by 10. Now, all the countries that use the metric system, they may not know how to make a plate of barbecue, but they definitely know how to come up with a measurement system because this makes conversions easy, easy, easy. Every now and then I think, you know what? America's ready to turn the corner. We're ready to go metric, and then it never happens. I think there was a big push for it in the 70s to convert us to metric, and it never happened.
Jimmy Carter.
Yeah, yeah. I think the reason it never caught on is because of older people. If I said, okay, starting tomorrow, you're not allowed to say miles and feet anymore. You got to say meters and kilometers. People wouldn't know how to communicate with each other. If your speed limit sign said the speed limit was 75 kilometers per hour, is that fast or slow?
Slow.
Is it? I don't know. I don't know metric system. How fast could you go in a school zone in kilometers per hour? I mean, assuming you didn't want to run over any kids.
I mean, I feel like.
Yeah.
Super slow.
Yeah. If a person told you they were 2 meters tall, is that person freakishly big? Are they really big? Are they kind of like average height? What if they were 1.5 meters?
1 meter equals.
If I said that I was 150 decimeters tall in my online dating profile, would you be like, "Ooh, it's a tall guy," or would you be like, short guy"? It's hard to just switch over right away, but we're gonna do our best. We're gonna do our best.
So do foreign cars say miles per hour MPH or like miles per hour, whatever? Or?
I don't know if they have both. Like those old school American speedometers have miles per hour and kilometers per hour on them. If you buy a foreign car, I don't know if it has both. That's a good question.
Drove in Germany.
Uh-huh.
The BMWs did have both.
They have both on there?
Yeah.
Yeah, that's a good
Yeah,
question.
so.
I know if you work in a shop, it drives you nuts that some of your tools are in the Imperial System or some are in metric, and they never quite fit right if you get the wrong measurement. So if you're going to be a shop guy someday, prepare to be annoyed by the mixing of the two systems. Let's convert 2.3 meters to centimeters. These conversions are easy for a couple of reasons. One of the reasons they're easy is because dividing by 10 and multiplying by 10 is all you do ever. I don't have to worry about like how many decimeters are in a meter. It's 10. It's a multiple of 10 every time. So that automatically gives it an advantage over like feet, inches, miles, yards, etc. But the other reason it's really great is because multiplying by 10 is easy. What's a really fast way to multiply a number by 10? You just add zeros. What's a really fast way to divide by 10? You take away zeros, and when you run out of zeros, what do? You start moving the decimal. Start moving the decimal to the left or the right. Okay, multiplying by 10, you move the decimal to the right. Dividing by 10, you move the decimal to the left. Okay, so let's do it. 2.3 meters to centimeters. So the first thing I'm going to do is go to my little chart here. Here I am at meters. This is what I'm given. I want to convert to centimeters, which means I go how many spots? 2 spots to the right. When you move right, you multiply by 10 for each step. So this was 1 step, 2 steps to get from meters to centimeters. So I'm going to multiply by 10 twice. Okay, here we go. What's 2.3 multiplied by 10?
23.
So 2.3 meters equals 23 decimeters. Multiply by 10, I go from meters to decimeters. But I didn't want decimeters, I wanted centimeters. So we multiply by 10 again. 23 times 10? 230 centimeters. No goofy fractions, no memorizing measurements. You're just moving the decimal back and forth. I believe, one of you nursing experts can correct me, I believe millimeters is the same thing as a cc. Is that correct? Milli is the same thing as a cc? Probably not millimeters, but milliliters. We'll talk about liters in a minute. Is that a cc? A milli cc? Someone says yes, and I believe you. Okay. Cool. Millimeters to meters. Okay, so here I am at millimeters. I want to get to meters. So let's count how many times I'm moving. 1, 2, 3. So I'm 3 times to the right or left? 3 times to the left. When you move left, you divide by 10 for each step. So I've got my 450,000 millimeters. If I divide that by 10, what do I get? Just lop off a 0, right? So 45,000 centimeters. That's if I go left 1 time, I'm at centimeters. Okay, I don't want centimeters though, so let's keep going. Let's lop off another 0. That's 4,500 decimeters. And if I divide by 10 one more time, I get 450 meters. $450 meters. That's big. If somebody says they're 4,500 decimeters tall, they're either a liar or they're terrible at math. Maybe both. Okay, we're just sliding up and down the steps here. It's not that big of a deal, right? Right? Confirmed? Not that big of a deal? So let's do some subtraction then. Imagine if I did 1.3 kilometers and I said to subtract 430 meters. It's a little bit of a disadvantage here for the metric system in that you can't subtract 2 units unless they're the same. So before I can do anything, I have to convert both of these to the same unit. It doesn't matter what unit that is. I have kilometers as my first number, and I have meters as my second, so I could either convert the kilometers into meters, so that these are both meters, or I can convert the meters into kilometers, so that they're both kilometers.
I like converting them to meters.
I like converting them to meters too, so that we can avoid decimals. If we convert the kilometers into meters, we won't have any decimals here. So let's do that. To go from kilometers to meters, what do I do?
Times 10.
Multiply by 10 how many times? 3 times. Multiplying by 10 3 times is the same thing as multiplying by 1,000. So I'm going to do 1.3 kilometers. I'm going to multiply that by 1,000. So if I multiply by 10, it's 13. If I multiply by 100, it's 130. If I multiply by 1,000, it's 1,300. So 1.3 kilometers is 1,300 meters. Now that these are both meters, really easy. I'm just going to subtract them. The first number, 1,300 meters, minus the second number, 430 meters. That's not too bad. So the answer is 870 meters. Or if you really wanted to, like since kilometers is one of our answers, you could also convert that back to kilometers by dividing by 1,000. 0.87 kilometers. Either one of these answers is good. Meters or kilometers, just kind of whatever you feel like. And this answer makes sense. I had a little bit more than 1 kilometer. I subtracted some stuff. Now I got a little bit less than 1 kilometer. That makes sense. I got good news about multiplication. Multiplication, I don't have to worry about converting units. I do 5.7 times 4, and the answer is in millimeters. That's nice. So 22.8 is what I get when I do 5.7 times 4, and the answer is millimeters. So that one's much easier.
Like that when you multiply?
Yep. When you multiply by a number, you don't have to worry about units. And that's kind of all there is to that. If you were going to subtract, like if I wanted to do, let's say 1.2 meters minus 0.14 centimeters, you do the exact same thing that you do with addition, which is that you convert to the same unit. Could you?
Yeah.
Sure.
What would that look like if you're dividing?
If it was just dividing by a number, you just take this and divide by the number, and then that's it. If it's like millimeters divided by millimeters, then your answer would just be a number with no unit. And if your answer was like millimeters divided by meters, you would convert them into the same unit and then divide. I wouldn't spend too much time worrying about that, though. You are unlikely to have problems like that. So again, I need to convert to the same unit. 1.2 meters could be converted into centimeters, or I could convert the centimeters into meters. Doesn't matter. So what do you want to do?
Meters to centimeters.
I agree, because converting centimeters into meters is going to give me a tiny, tiny number. So meters to centimeters it is. I need to multiply by how much?
1, 2.
Twice, right? 10 times 10, which is 100. So I do 1.2 times 100. 1.2 times 10 is 12. Times 10 again is 120. Minus, I assume you all remember how to subtract decimals, line up the decimals. If you don't remember how to subtract decimals, whatever you do, don't admit it. 119.86. Any questions about linear measurement?